GitHub is a web-based platform that serves as a central hub for version control and collaboration on software development projects. It uses the Git version control system to track changes to files within a project, enabling developers to work together seamlessly and manage their code effectively. In the context of AI development, GitHub plays a crucial role in facilitating collaboration among data scientists, machine learning engineers, and other professionals involved in AI projects. It provides a centralized location for storing AI models, datasets, code, and documentation, making it easier for teams to access, share, and review contributions. GitHub's features such as branching, merging, pull requests, and issue tracking help streamline the development process and ensure the integrity and quality of AI projects. Additionally, GitHub serves as a repository of open-source AI projects, libraries, and tools, allowing developers to leverage existing resources and contribute to the advancement of AI technology. Git is a distributed version control system, VCS, that enables developers to track changes in source code during software development. It allows users to manage their code repositories locally, providing features like version tracking, branching, merging, and collaboration. GitHub, on the other hand, is a web-based platform built around Git, offering hosting for Git repositories and facilitating collaboration among developers. It serves as a central hub for storing, sharing, and managing code, providing additional features such as issue tracking, pull requests, and project management tools. Together, Git and GitHub form a powerful combination for version control and collaborative software development, enabling teams to work efficiently on code bases while maintaining a comprehensive history of changes. This integration of Git and GitHub plays a crucial role in modern software development AI workflows, ensuring code reliability, collaboration, and project management efficiency. Creating a GitHub account is the first step towards leveraging GitHub platforms for collaborative software development and version control. To create an account, visit the GitHub website and click on the Sign Up button. You'll be prompted to enter your desired username, email address, and password. Once you've provided the required information and completed the registration process, you'll have access to your GitHub dashboard, where you can create repositories, collaborate with others, and contribute to open-source projects. Installing Git and configuring it with GitHub is essential for seamlessly integrating your local development environment with GitHub's collaborative features. After creating a GitHub account, the next step is to install Git on your computer. Git is available for Linux operating systems and can be downloaded from the official Git website. Once installed, open a terminal or command prompt and configure Git with your GitHub account credentials using the git config commands. These commands set up your username and email address, which are used to associate your commits with your GitHub account. In the context of GitHub, it is essential to know some of the terminology. A repository, often abbreviated as repo, is a storage space where project files, such as source code, documentation, and assets, are stored. Repositories on GitHub can be public, accessible to anyone or private, restricted to specific users or teams. A commit represents a snapshot of the project at a specific point in time. It captures a set of changes made to project files since the last commit, along with a descriptive commit message explaining the modifications. Commits provide a detailed history of project development, allowing collaborators to track changes, review modifications, and revert to previous states if necessary. A branch is a parallel line of development within a repository. It represents an independent workspace where developers can work on features, fixes, or experiments without affecting the main code base. Once changes in a branch are complete and tested, they can be merged back into the main branch or other target branches. Cloning refers to the process of creating a local copy of a repository from GitHub onto your computer. This local copy contains all the files, commit history, and branches present in the remote repository. You typically use the git clone command followed by the URL of the repository to perform cloning. Pulling involves fetching changes from a remote repository and merging them into your local repository. It's used when you want to update your local repository with the latest changes made by others. The git pull command is used to perform this operation. Pushing is the process of uploading your local repository's commits to a remote repository on GitHub. It's used to share your changes with others or update the remote repository with your work. The git push command is used to push commits to a remote repository. Merging is the process of combining changes from different branches into one. It's commonly used to integrate feature branches back into the main branch. A GitHub repository, often abbreviated as repo, is a location where files and folders are stored for a particular project. It is as a central hub storage location where all project files and their revision history are stored. Repositories can contain code, documentation, images, and other project-related files. The structure of a repository typically consists of directories, subdirectories, and individual files, organized according to the project's needs. Each repository also contains a readme.md file, which provides an overview of the project, instructions for getting started, and other important information. For example, contributors can clone the repository to their local environment, make changes, and submit pull requests to propose modifications. The structure of a repository typically includes the components like main directory, readme, subdirectories, and files. The repository can have multiple branches, each representing a different line of development. For example, the main branch typically contains the stable version of the project, while feature branches may contain work in progress. The commits represent individual changes made to the files within the repository. Each commit has a unique identifier, a message describing the changes, and a timestamp. Initializing a GitHub repository involves setting up a new repository on GitHub's platform to store your project's files and track their changes. To initialize a GitHub repository, log into your GitHub account, navigate to the GitHub website, and click on the plus icon in the top right corner. Select New Repository, provide a name, description, and choose whether it will be public or private. Once the repository is created, you need to initialize a Git repository locally on your machine. Navigate to the directory containing your project files in your terminal or command prompt and run git init to initialize a new Git repository. Then, add your project files to the repository using git add and commit them with a descriptive message using git commit-m with initial commit description. After initializing your local Git repository, you need to link it to the GitHub repository. To do this, add a remote reference to your local repository using git remote add origin GitHub repository URL name. Finally, push your local commits to GitHub using git push-u origin master, assuming your main branch is named master. This establishes a connection between your local repository and the GitHub repository, enabling you to push and pull changes between them. Cloning a repository is a fundamental operation in Git, allowing you to create a local copy of a remote repository. This process is essential for collaborating on projects, contributing changes, or simply working on your own projects locally. To clone a repository, you first need the URL of the remote repository you want to clone. Once you have the URL, open your terminal and navigate to the directory where you want to clone the repository. Then use the git clone command followed by the repository URL. For example, if you wanted to clone a repository named my_project owned by username, the command would be git clone https://github.com/username/my_project.git. After running the command, Git creates a new directory named my_project and downloads all the files from the remote repository into it. You can then navigate into this directory and start working on the project locally. If there are any updates in the remote repository, you can use the git pull command to sync your local copy with the latest changes. This process enables seamless collaboration and version control in software development projects. Adding and committing changes in a Git repository is a crucial process for tracking and managing modifications to your project files. After making changes to files in your working directory, you need to stage these changes for commit. To do this, you use the git add command followed by the names of the files you want to stage. For example, to stage a file named example.txt, you would run git add example.txt. Alternatively, you can use git add dot to stage all changes in the current directory and its subdirectories. Once you have staged the changes, you commit them to the repository using the git commit command. This command opens a text editor where you can enter a commit message describing the changes you have made. Alternatively, you can use the -m flag followed by a short descriptive commit message directly in the command line. After committing your changes, they become part of the project's history, and you can view commit history using the git log command. Committing changes regularly helps maintain a clear and organized project history, facilitating collaboration and tracking progress over time. Before we conclude this GitHub course, we want to extend our heartfelt gratitude for your commitment and passion throughout this learning experience. GitHub is more than just a tool. It's a vital platform that facilitates collaboration and version control in the world of software development. Your dedication to mastering GitHub is commendable, as it signifies your readiness to engage in collaborative coding projects and contribute to open source communities. As you continue your journey with GitHub, remember that the skills you've honed here are invaluable. They empower you to efficiently manage projects, track changes, and work seamlessly with teams, fostering innovation and efficiency in software development. Keep exploring the capabilities of GitHub, experimenting with its features, and applying what you've learned to real-world projects. Your proficiency with GitHub will undoubtedly open doors to exciting opportunities and propel your growth as a developer in the dynamic realm of technology.